YouTube channel, Senior Fellows. For today's topic, we are still on commerce, and our topic for today is percentages. These are our objective. So we will be doing all this under percentages. What is a percentages? A percentages is a fraction with a denominator of 100. So any fraction with a denominator of 100 is a percent. So we read it as a percent. And this is a typical example of a percentage is 3%. Now let's move to the real life application on percentages. So you have a phone and your battery is draining off. Then you say that your phone, my battery percent is 5%, 50%, and so on. So we use percentages in our daily life, and this is a typical example: compound interest, bank interest. On all these things we deal with what? Percentages in our daily life. Okay, now sales, 100% sales of another sort. Maybe there's a discount on the shirt and there's a reduction in price, and all this is application of percentages. So in our daily life we deal with percentages. Good. So let's move on from the application of percentages in our daily life. Good. Let's revise ourselves on percentages. So this is a revision. Let's see, we can do this. Write the following as percentages. Write the following as percentages: 50 out of 100, 40 out of 100, 3.2 out of 100, 167 out of 100. So let's see, what are your answers? Good. So 15 out of 100 is 50%, 40 out of 100 is 40%, 3.2 out of 100 is 3.2%, 167 out of 100 is 16%. Very good. Let's try another one. Express the following percentages as a fraction in its lowest term. So you just express this as a fraction. So I'm waiting for your answers. 28%. You express it as a fraction and you reduce it to the lowest form. Good. So we are doing a revision. Let's recall. Good. Let's compare the answers. Then 28 out of 100. If you reduce it, you will get 7 out of 25. 35 out of 100. If you reduce it, you will get 7 out of 20. 0.5 out of 100. And what is 0.5? Yes, out of 100 you get 1 out of 200. That's what? Half percent. Good. So this is percentages. Okay, now under revision, change the following to percentages. So how should we change them to percentages? So we change the following to percentage. 2 out of 5. Yes, I'm waiting. We are just revising ourselves on percentages. Good. So here you have to multiply it by what? 100. Then you can change it. So if I want to change a fraction to percentages here, just multiply it by 100. Then so 2 on 5 times 100, you have 40%. 40%. Good. Yes, good. Okay, this one too. 3 on 4, you had 75%. Rewrite the following as percentages. Rewrite the following as percentages. You are still doing the revision. Yes, 0.475. 0.475. It says we write this as percentages. We write this as percentages. Good. Let me help you here. You can change this one to fraction form, then write it as percentages, or you can multiply this by 100, then you get your answer. So let's see, compare our answers. 0.47 times 100, you get your answer. Or you can rewrite this in a fraction form, and any number with a denominator of 100 is a percentages, and it's a typical example of it. Good. Here's some derivation on percentages. And number 5 is arrange in descending order. And we know how to arrange numbers in descending order from the highest to the lowest. Good. So if you are given this and they ask you to arrange this one in descending order, you did this as you are in a basic school, so you are still doing a revision. So let me give a clue. You just multiply this by 100. It's already in percentages, so just multiply this by 100, this by 100, this by 100. Then you compare it, then arrange it in descending order. So there's some revision solution, and this is what you get. Yes, you had this. So this is the solution. So then let's arrange it in descending order. This is the highest, and that's 5.4. That's why it's here. After that, we have the 60. That's 3.5. That's why it's here. So in descending order. Yes, so you have done a revision. The same thing. 6. Arrange it in descending order. Good. So solution. I'm waiting for your answers. Yes. Good. This is your answer. So the next one, arrange in ascending order. So you just arrange this in ascending order. Solution for this is this, and another one is this. Very good. So you pause it, you do it, then you compare your answers. So we are just revising ourselves before we move to the main topic, percentages. So you are still in revision, and this one is still in descending order. So you see, I arrange this one in descending order. Like I said, you just pause the video, then you compare your answers. Very good. So these are your answers, the answers that you get. Good. So all these are for the revision or not percentages. We just revise ourselves, do some recall. Yes, do some recall. Now it's time for business. So our topic was percentages. So now we are going to start with the percentages. The one we are doing was just recall. Good. Now we are going to compare percentages. So percentages of a given quantity. Percentage of a given quantity. So here we are just going to express the percentage as a fraction and multiply by the given quantity. Multiply by the given quantity. So I have these examples. Example 1. Find 35% of 400 Ghana cedi. We should find 35% of 400 Ghana cedi. So you just said that you express this as percentages as a fraction, then multiply by the given quantity. And here the given quantity is what? The 400 Ghana cedi. So solution. Good. So 30% of this. Very easy. So just make use of your calculus, or you can just go by your JHS. This will cancel it, and this will cancel. Then 4 times 35, you had this as your answer, 140 Ghana cedi. Question 2. What is 25% of 80 books? So it means that you expect this as a fraction. Then 25% of 80 books as a fraction. Then we have this. So you just continue. This 0 go here, 8, then 5 goes here, 5 goes here, 2 goes here, 2 goes here. Or you can make use of your calculus, and if you do that, you'll get 20 watts. That's 20 books. 20 books. Good. Find 2.5% of 20 Ghana cedi. So we just express it as a fraction. 2.5% of 20 Ghana cedi, and 2.5% is the same as 2.5%. Good. So you change the 2.5% into a fraction. That's why we did the revision. You know how to do it. Then multiply by the 20. Then you will get what? 0.5. That's what? 0.5. So that's what? 50 pesos. So 0.50 pesos. That's what? It's now 2 Ghana cedi. Good. Then, given that 7.5% of k is 33, find k. So mean that here you have to change this one to a fraction. Solution: 7.5 is same as 7.5 of k. So 7.5 will be multiplied by the k, then equals what? 33. Then you find k. Very simple. You make k the subject. That's what we are saying. Good. So here, to make k the subject, you just multiply both sides by 100. You multiply both sides by 100. Multiply here by 100. Always get rid of the denominator. Okay, you get rid of the denominator, 100, so that this will cancel and this will cancel. Then you have this. Yes, very simple. So 7.5 times k, and this times 100. Then you make k the subject. So from here, we have to find k. So the 7.5 is attached to k. So you divide both sides by 7.5, so that you remove the 7.5 from there. You cancel, then this is it. Therefore, your k is 400. 400. Very simple logic. Okay, it's very simple. It's very simple and very nice too. Good. Move on to the next one. We are still on comparing percentages. Express one quantity as a fraction of the other. We have to express one quantity as a percentage of another. Now, to express one quantity as a percentage of another, S as a percentage of Y is S out of Y times 100. Yes, so you have to express one quantity as percentage of the another. This is how we do it. So example, S as a percentage of Y is S out of Y times 100. Now, let's take note of this. We are saying that percentage of Y. Why is the Y the denominator? Is because of what? Off, then Y comes off, then Y comes. That's why that make the Y as what? The denominator instead of the S. So express this as of Y. Example 1. Express 25 as a percentage of 75. So the of 75, this will make the 75 what? The denominator. So you just express this as a fraction first. So it will be 25 out of what? The 75. Then you multiply by the 100%. Multiply by the 100. Okay. Then if you use the calculus, you'll get this. So here, make use of the calculus, or you can go with the manual way. This reduced by this, this reduced by this, and that is also there. Okay, you can make use of the calculus. Very simple. Good. The next example: what percentage of S is 0.25? Then so which one will be the denominator and which one will be the numerator? So you have to express this in a fraction, then you multiply by what? Percent. Because you say what percent? I told you we are doing the revision. We have 2 out of 5. Change this percentage, you multiply by what? 100%. Okay, good. So here I always advise you that look of what? The of. So of 5. And this will make this what? The denominator. So it will be 0.25 out of 5 times 100 times 100. Then you will get this 5 out of what? 100. 5 out of 100%. 5 out of 100%. So 5 goes here and 5 goes here. Good. So 5 goes here, 1. 5 goes into 10, 2. You can use the manual. Then 0 here. Then this time this, you will get the 5%. Okay, the 5%. So make use of the calculus. Make use of the calculus. And the example, I like solving more examples. Yes, well, I like solving more examples. What percentage of 250 Ghana cedi is 50 Ghana cedi? What percentage of 250 Ghana cedi? So which one is our denominator here? Yes, good. That's what, the 250 Ghana cedi. So because of the of, then this make what? Our fraction, the denominator. So just multiply by 100. Just multiply by 100. Then you'll get this as what? 20%. 20%. 4. Express 190 girls as a percentage of 250 people. You express 190 girls as a percentage of 250 people. Yes. So from here, which one will be our denominator? I'm waiting for your answer. Good. So this is the denominator. So it's what? 190 out of the 250 times 100. And you have this as your answer. Very simple. Very simple. This is very simple. Very simple. Let's continue. Percentage change. Percentage change. So here the change can happen when there's an increase or decrease. Or the change can be increase or decrease. Okay, good. When it change, is either it will change positively or it will change negatively. Okay, so that's percentage change. So it will be increase or decrease. So the change is always out of the original price times what? 100, where the change is the difference between the original and the new quantity. Good. So this is the form of finding percentage change. Now, percentage change is same as the percentage increase or decrease. So if the change is out of the original price times 100, then what is percentage increase? Okay, so this one refers to how much a value has grown, expressed as percentage of its original value. So how much a value has grown, that's the increase, and the increase will be increase out of the original times 100. So it's the same as the change. Okay, that's either increase or decrease out of original price. Then we have percentage decrease. That one is refers to the reduction in value, as the increase was talking about how much a value has grown. And this one refers to reduction in value as expressed as percentage of what? Its original. And that one will decrease out of the original price times 100. So that's for percentage change. So we go and solve more example on percentage change. Yes, percentage change example. This is our first example on a percentage change. The population of Ghana was 5 million in 1957. The population in 1998 was estimated to be 17 million. Find the percentage increase in the population from 1957 to 98. Good. So here the question I've given you a clue, find the percentage increase. Sometimes it can be silence. Okay, so since it was 5 million, now it's to 17 million. So there's an increase. They said they want the percentage increase. So here you have to know the change. Okay, the difference. So solution, they know that percentage increase is the increase times the original price. So before we get the increase in the population, we have to know the difference between them, okay? So the highest minus the lowest. So 17 million minus the 5 million, you have for 12 million. And that's the increase. So that's the increase in the population. But they say they want the percentage increase. So you have to express it as what? In a fraction form. And that's why we are saying that the increase is out of the original price, okay, or the original value here. So here, the increase here, this one is our increase, and our original value here will be what? The population, the original population will be what? Yes, the original is what was before moving. So it was 5 million before moving to the new one. So the 5 million here is the original, okay? What was before moving. So it was this, that's the original. So here we have for 12 million out of the 5 million times 100, because we are changing to percentages. We do it percentages. You are just changing into percentages, okay? It was this increase. This is the increase, but I want the increase in percentages. And if you do it, you get 240. So this will cancel, this will cancel. 5 goes here 1, 5 goes here 20 times 12, that's 240. Or you can make use of your calculator. If the length of a skirt is decreased from 27 centimeter to 24.84 centimeter, calculate the percentage decrease. Calculate the percentage decrease. So if the length of the skirt, so students always cut their skirt. Yeah, at first year you see them as us. Yeah, they are skirt like woman sisters. Now if they reach on the third year, you see them their skirt be short. So now, yeah, they are seniors and cool. Good. So solution. So the skirt is decreased from what? 27 to what? 24.8 centimeter. Well, castle. Yeah. You must have cut out the skirt. Okay. Good. So percentage decrease is decreased out of the original price times 100. So the decrease, let's subtract the highest from what? The lowest. So 27 minus the 24 before we get a decrease. And this is the decrease. 2.26. But we want it in percentages. That's why we have to express it in percentages. So the decrease is 2.26 out of the original. Then our original is what? 27. Like always, to find the original is very easily. What was before moving? So it was 27 centimeter before moving to what? Days. So the original price at first was what? 27. That's why I have what? The decrease out of the original times the 100%. And if you make use of your calculus and use your own algebra, you had what? 8%. And that's what? Percentage change. So let's move on to another example on percentage change. So the third example, this one, you will do it for me. Then you just compare the answers. Okay, good. I put this question for the new curriculum people. Oh, yeah, good. From the new curriculum. That's very nice question in there. So the third question is, in July 2021, there was an increment in the price of diesel per liter from 9 cedi 50 pesos to 13 cedi 20 pesos, which later declined to 12 cedi 50 pesos. Find A, percentage increase, B, percentage change. Wow. Solution. So this one, I hope you can do this. Yes, do it and compare your answers. So pause it, you do it and just compare your answers. One, to find the percentage increase, that's what, the increase out of the original times 100. Very simple. Now, in July 2021, there was an increment in the price of diesel per liter from 9 cedi 50 pesos to 13 cedi. So there was an increment from 9 cedi 50 pesos to 13 cedi 20 pesos. The petrol. So We just increase, we just find the difference, then out of the original. So the original, at first it was 9 cedi, 50%. That's the original price. Okay, good. So you multiply by 100. That's what we are doing. Very simple. Then you had this. Very good. Now, percentage decrease. With the decrease, solution for the decrease, which is the decrease out of the original times 100. That's percentage decrease. Now, the decrease is which later declined to what? 12 cedi, 50%. So 9.5 to 13 cedi, 20%. So now it was 13 cedi. Then it reduced. Maybe there's reduction in the dollar. It reduced to what? 12 cedi, 50%. So it was 13. So now our original for this is 13, then reduced to this. So you find the difference. Yes, 13 minus this, because of it was this before reducing to this. So this is our original price. That's all for the 13 cedi, 20%. Then multiply by 100, and this is your answer. Very simple. Good. So let's move on to the next one, which is percentage error. Percentage error. So as for error, it's always introduced when an approximation is made. An approximation is made. Good. So let's talk something about error. That's why in examination we always ask you to, if you want to run a decimal up, just run it up to 4 decimal places. Okay, good. If you run it more, your final answer, there will be a huge error. There will be a huge error. Now let's talk about the pi value, which you know that pi is 3.142. Yes, 3.142. Good. And that's not pi. That's why I say take pi as. That's not pi. Pi continue 3.142 and more numbers is what? Yeah, it continues to. So pi is irrational number. It goes on and on and on and on. Good. So we just run it as what? 3.142, and it's an error. Okay, it's a typical error of pi. Good. So we have the error is what? Absolute. The error is absolute error out of the actual value times 100. And the absolute error is simple, the difference between the two values, like the percentage change where you're doing the decrease or increase, or the difference between the two values. Good. So this absolute error out of the actual one, that's percentage error. So example, find the percentage error in approximating 2.7 as 3. So the person just approximate 2.7 as 3. There's an error. Okay, there will be an error. So we want to get the error margin there. So you have a question exams, then you had 2.7, then you just approximate it as 3. It will affect your final answer. Yes, good. So there's an error. So solution, how to get the error is what? The absolute error out of 100, and it says that the absolute error is the difference between the two values. So the difference between these two values. Good. And out of the actual value, the actual value is what? The original, where it was before moving. Yeah, that's the actual value. So the actual value is what? 2.7. Okay, not 3. It was 2.7. Then the person approximated, that's the actual one, times 100. So it's just like the percentage change. Very simple. And this is the error. You see the error that you have made? 11.1. 11.1 error. Yes, that's 11.1. Since the person approximated it to what? To 3. So that's for percentage error. There's another example here. Example 2. Yeah, pi. Pi. I really like pi. The value of pi contains. So let's talk about more pi. That's 3.142. Yes, it goes on and on and on and on. Okay, good. And we always celebrate International Mathematics Day. On which day? That is on the 14th of March. March is 3. So every 14th of March is International Mathematics Day. So 14th of March, International Mathematics Day. In the whole world, we just celebrate International Mathematics Day. That's very nice. Okay, good. So the value of pi equal to 3 decimal place. Find equal to 2 significant figure the percentage error in taking 3.14. Read error in taking 3.14. So the person make an error. I think the person just ran the 3.14 through and get to a 3.14, and there's error. They say we should find it solution. So percentage error, just absolute error out of the original or the actual. It was 3.142 before moving to 3.14. Okay, so this is the original, the actual one. Okay, before the person make it what an error of this. So you want to know the error margin, make use of your calculus. The error margin 0.06% to 2 significant figure. So 2 left is so it's supposed to be 0.06, maybe 2. Okay, there's 2 here. That's what 2 significant figure. The third one, I like some more examples. A student measured the length of a room, obtained 3.9 meters. So a student measured the length of a room and obtained 3.9 meters. If the percentage error of his measurement was 5% and his own measurement was smaller than the length, what is the length of the room? So let's see this question. A student measured the length of the room and obtained this. And obtained that. So the person measured the length and obtained this. If the percentage error of his measurement was 5%, so here we are giving the percentage error. And his own measurement was smaller than the length. So which means that we don't know the length. What was the length of the room? So they said his own measurement. So his own measurement was what? 3.9. So his own measurement was smaller than the length. Meaning that the length is bigger than what? The room. Okay. What is the length of the room? So this percentage error. So solution, we let S be the actual value. That's the length of the room. Okay. That's the length of the room. That's the actual value. Okay. So here we're not giving the actual value. That's the length of the room before he went to do what? To measure it. And we understand his own measurement was smaller than the length. So this is a typical application. So this is a percentage error formula. That absolute error out of the actual value. We don't know the actual value. You see, always we just make the difference. Is the actual, and there's this, okay, and the actual value was the largest one. So since it is bigger, so we're giving the percentage error as 5. That's 5% here. Then the actual or the length of the room, because for me it said that his own measurement was smaller than the length, so it means that the length is bigger. Okay, so subtract the bigger, so that makes it what? The actual one. Then you multiply by 100. It was 5%. Okay, if you bring the percentage here, you just move this 100. So this was 5. Because there's already 100 here, there's no need for us to bring the percentage again. So then we just wait for S. This is very simple. Multiply both sides by what? The S. Okay, just multiply both sides by the S. Very simple. Okay, then you have for 5S. Then I'll divide both sides by 100. Then I have this. So this one, you make use of the calculus. I multiply by here S, and this S, and multiply here too by S, and this S, and this S will cancel. Okay, good. So I have 5S here. Then I'll divide both sides by 100. Then divide here by 100. Then after getting this, then divide both sides by 100. Then 5S out of 100. Then you get 0. So if you divide both sides by 100, you have this. Okay, 5S. 5 out of 100 is 0.05. Then you group like tens. They make S the subject. Yes, group items, then make S the subject. So this S can come here, or this one will come here, and this one will come here. Then you make S the time. You know how to solve this algebra work. Good. So now our next one is to increase or decrease a quantity by a percentage. So decrease or increase a quantity by a percentage. You work out the actual increase or decrease, then you add it to or subtract it from the original quantity to give the new quantity. So you work out the actual increase. When it's increased, you just add it to the original quantity. That's what you are saying. When it's increased, you just add to the original quantity. When it's decreased, after working out, you just subtract it. Very easy. Good. So to increase or decrease a quantity, if y is increased by s%, maybe that's what s out of 100, you get the answer. Then since it's increased, you just add the answer to the original one. Oh, good. Very simple to get what the new value. The new value. The same applies to the decrease, the same formula, s out of 100 times the quantity. As I'm getting the answer, since it's decreased, you just subtract it from what? The original to get the new value. Very simple. This is very simple explanation. So to increase or decrease, very simple. Okay, if it is increase, you just work out, after working out, you add to the original value. Decrease, you just subtract from the original value. That's very simple. So to increase or decrease a quantity by percent, example, increase 500 Ghana cedi by 30%. We deal with this, how to express percentage by a quantity. That's the percentage times the quantity. That's what we are doing here. But this time it's increase. So since it's increase, after getting the answer, then you add what? The quantity to get a new value. So 30% times the 500, you will get this. Since it's increase, then the new value will be 500 plus 150. Very simple. Decrease 400 Ghana cedi by 10%. So it's like to get a quantity, 10% of the 400. Then since it's decrease, we will subtract the answer from the quantity, and that is 400 minus 40. Good. So we dealt with this earlier on. The population of Eswafua JHS was known to be 540 in 2010. 2 years later, it was increased by 20%. Find the student population in 2012. Solution: 20% of the 540, because it said that it increased by 20% in 2 years later. Okay, so therefore this is the answer, 108. But since it increased in 2 years later, it's increased, so we just add the answer to the previous population. Okay, then the 2 years later, the people increased to 648. Okay, so that's the 2 years later, and that's for to increase a quantity by percent. Very simple. Subscribe to Senior Fellows, my YouTube channel, for more videos as we are moving to application.